So I just started learning Clojure, and I would like to share with you one of the main reasons for doing so. And I'm going to do that by showing the classical account problem in Java. And that normally takes 30 minutes to present. I'm going to do this in less than 2 minutes, so pay attention. Now here's an account class. It has two fields, a balance, which is long, and an account number, which is final int. And it has a couple of methods for manipulating the balance and a couple of methods for retrieving the values. So is this thread safe? Absolutely not. The minus equals and plus equals operators are actually 3 operations, although it seems like it's 1. And also, operations done on a long is not necessarily atomic. So we must synchronize all access to the balance field. We can do this like this. Now we have a nice and thread safe account class. The account number field we don't need to worry about because it's final. So let's do something more interesting here. We make a transfer function. It takes from account and a to account and an amount. The first thing you do is check if the from account has enough balance, and if it does, then you debit and credit. Is this thread safe? Absolutely not. And to make it thread safe, we need to use the same locks that we used in the accounts. And in the account class, we synchronize on the methods. That basically means that we're synchronizing on the account instance. So then we should just be able to throw up a few synchronized blocks, right? Now this might be thread safe, but we now introduced a new problem, which is deadlock. With a little bit of unlucky timing, 2 threads can enter this function with basically the same 2 accounts, just in different places, and they may deadlock. So how do we fix that? Well, we can use lock ordering. So the accounts have an account number, and we can use that. So here we determine which lock to use based on the highest account number. So the highest account number is the lock that we use first. Whew. All right, so that was only one mutable field. Imagine what that's like in a real application. This is all the code that I showed you, and so far. And this code is actually really hard to reason about. And I can honestly say that I don't know if this code is correct or not. What's even worse is that this code is extremely hard to test. So what is the problem here? Well, we're using explicit locks, and that is inherently difficult to program. So there must be a better way. Well, Clojure is at heart a purely functional language, which means that basically everything is immutable. So for instance, if you create a list, you can never ever change that list. You can only create new lists based on the old one, but the old one always remains the same. This means that you don't have any mutable data to synchronize on. And then a lot of the problems from Java just fall away, basically. But the account problem is a problem where you actually need to have mutable data. So Clojure lets you have mutable data through indirection of a type called managed references. Now, there are several different types, but the one I'm going to look at is called a ref. And a ref can only be changed within a software transaction. Software transactions have a lot of the same characteristics as database transactions, such as you can only change it, either everything happens or nothing happens. So let's look at the code. This is all the code there is. But you might be thinking this. Well, yes, it is a list, but this is extremely powerful. So let's see what it does. The reducing block here starts a transaction, and everything that follows either happens or it doesn't. So let's create a couple of accounts, and then we use the ref type that I spoke of earlier. And we'll call the transfer function, and this works as expected. The account gets the new value. If we try to alter the account outside of a transaction, Clojure would actually throw an exception at you. You're not allowed to do that. So I would think that this is a lot simpler to do, to handle than the Java version. This is a lot easier to reason about, and it's also a lot easier to test, since there's no way that you can get a deadlock from this. Alright, time for one final slide. The pragmatic programmers say that you should learn a new programming language every year. Hopefully I've inspired you to take a look at Clojure. Alright, thank you.